Sorry, how do you get the communication if only one head belongs to the shell? You know, when you do active across two heads, there's only one head that's really this is reserved to the shell. So if you're doing multipathing to the other head, if you're talking to the hyper channel adapter, the other head.
So the question was about reserving shelves and so on, but there's also a reservation issue in that we don't. Our reservation isn't a strict SCSI reservation. So it's.
They have a principle of ownership. If you have to have configuration, you're supposed to one head will make some one part another how it's always completely symmetrical and it can be accessed from both heads.
Yes, we have mechanisms in place to stop concurrent access.
Multipathing in Windows, let's say Windows.
Yeah.
How it reports from the back, like on those SCSI commands, it should report like active with symmetrical, asymmetrical, optimized, not optimized that. So multipathing, it's what it's now doing in SCSI, it reports back to the server what path is optimized, what's non-optimized, or both are optimized. What you report is that both are symmetrical, both paths from both heads, or they're asymmetrical. What exactly?
It's asymmetrical.
Asymmetrical.
Yes.
So you have one optimized path, one unoptimized path. Yeah. So that means you have an ownership of the let's say one head owns one set of the disk volume and another set another volume. That's my question. Do you have a concept of ownership?
Yes.
When it's one fails, you actually move the ownership from one head to another.
Yeah, that's what it works.
Did you catch all of that? Because I'm not going to repeat it.
Basically, MPX or an MPI.
Yes. Yeah.
There's a very big FAQ on that.
So there is a big FAQ. If you go to high-availability.com/FAQ, there is an FAQ for how MPX.io is done, isn't it? Yeah. Okay. Options that you can set are the failover hostname, the virtual IP address, and the interfaces on each node that virtual IP address is to appear on. You can also set that there's a preferred node to run the service from. And that would be used, for example, in resolution of a ping pong, is that if we've been backwards and forwards a couple of times, we say, well, that's enough. You're going to go that way, you're going to go that way, and we'll leave it in a manual mode and wait for operator intervention before we do anything else. Some advanced options to do with timeouts, really. We typically have got an 8-second timeout to spot the one node going down and to start taking over the service. We have an initial timeout of 20 seconds to cope with the situation where both systems are coming up, still booting in parallel, because there's so much else going on that actually it's not. Experience would say wait a little bit before you get so aggressive, so you can have a 20-second timeout rather than an 8-second timeout there. And SCSI disk reservation, don't take that to mean necessarily that we use SCSI disk reservation per se. One of the features of the cluster is your system can query the state of all the disks in the cluster. So if you, at the command level, did an import without, just the ZFS import command, you would see all of the disks and all of the pools that are available. That's quite an important feature in the way that this is done. So we use the SCSI protocols as part of our IP. Part of the way that we add some value is and speed things up is to use other mechanisms towards the fast fail driver.
So it's SCSI 3 persistent group solution?
No, SCSI 3 persistent group. No.
The problem with using reservations is
soon as you reserve disks for one side, the middle of the side is single. So if you have a reservation place, then you can't we use a different mechanism to actually place this sort of watchdog on like this. If any other machine tries to access that input, then the other machine will have.
That's probably too much detail. Okay. Once the volume is added to the cluster, there's an option to do a hot restart. That's something that we're going to be changing. A hot restart will actually restart all the services.
Hot restart doesn't affect all the services.
Oh, it's a cold restart, yeah, sorry. Rewind. Just rewind that back a bit. The hot restart is, it doesn't restart the other. Okay, and once that's in place, you can see we've now got this volume 01 with this virtual IP address is now configured into the cluster.
Sorry, could you repeat one more time? What is the hot restart?
Sorry, the hot restart is only starting that one service. A cold restart would restart all of the services in the cluster.
The way we did it is that when you add a new service, you have to shut down all the services and then bring them back online. Now it's a hot restart. Basically just introduces all the moves volume of services without affecting them.
So that was a detail that I missed in the timeline as when that changed. Sorry about that confusion. Okay, so we've now got everything up and running. It says that the volume is available. And it's in an automatic mode, and we can now send a manual failover command if we want to fail it over from next test 3 to next test 4. And then there's also a thing that will just pull out relevant stuff from the logs if you have an issue. So it will just pull out the RSF relevant information if you're having a support issue, so that you can just send those particular cluster state changes and any diagnostics, to Next Center for your support. Okay. Then there are some global buttons right at the end. But basically, this is very simple. You initialize the cluster, and then you just add services to it. Everything else, as I say, your NFS, CIFS, iSCSI, fiber channel, exports. Oh, and the auto services. Any replication that you set up, any snapshotting, those move with the pool as well. Okay? Right, I'm going to finish just by talking about how we feel about the technology generally, just some more principles that are coming from this. RAID, what does the I stand for? Can we just see? Inexpensive. Inexpensive. This is the only bit where you're allowed to say cheap. Yeah. It should be noted, I think it was 1988 that David Patterson et al. Coined the term RAID, and it was a redundant array of inexpensive disks. I found with Google at least one document from 1994 from IBM that had used the term redundant array of independent disks. A company after my own heart. Because they know that good, cheap and fast, you can only have any two, just in case you've forgotten that. But when it comes to RAID levels, you can pick your NE2 as well, for example. This should be, this is where we're feeding into that. We're not great fans of RAID Z either. But we are big fans of ZFS. Now a little story from history. This is my reproduction of a page from a Bible that was printed 500 years ago in the City of London. And it was termed the Wicked Bible because it had so many typographical errors in it. If you haven't got to verse 14 yet, the trouble with corrupted data, adulterated data, is sometimes you prefer the adulterated version. The problem for these printers is they printed 1,000 copies and they had to burn them all. And they were fined £330, which 500 years ago was a lifetime's earnings. So for the last 500 years in London at least, a single bit error has been able to put you out of business. Because obviously the missing word not is a single bit error in logic terms, isn't it? It's a bit flip. And so we like ZFS, ZFS, or as my French-Canadian friend would call it, ZFS. We like ZFS because it delivers the RAID that it was meant to be, where I is inexpensive, where to a degree you can use cheap components and ZFS will save you from your own folly. Because one of the issues, of course, with cheaper drives is they don't use such good bearings on them. They don't use such high-quality components on the controller boards. SATA itself doesn't do very much in terms of detecting errors, let alone fixing them. I've even heard of somebody boasting in one of these forums that they would use a SATA to SAS interposer card that only costs $10. Now that may appeal to the cheapskates amongst you. I know there are some in the room. But when we're talking about availability, we are not going to go there, are we? Are we? No. But ZFS does use checksumming to protect its own metadata and your data. The copy on write nature of ZFS also means that it always has consistent state on disk, as long as you're using a good SSD, I suppose would be the caveat, because not all SSDs are equal, it would seem. No FSCK is required because of this copy on write, which means you get a faster reboot. When we're talking about high availability and we're increasing the number of nines, a fast cluster failover or a fast reboot is really very desirable, highly desirable, mandatory. It has both passive and active self-healing capabilities. So as you access data, it will spot data that is corrupted and it will fix it on the fly. Obviously it has more work to do with SATA drives than SAS drives. That's a fact, actually. I think an empirical fact. But you can also do scrubbing, which is one of the auto services that you could run. So it can actively go out and look for bit rot in the drives. And snapshots and clones are essentially free and unlimited. And that does open up the door for interesting replication and even DR opportunities. I've actually used it to improve scalability as well by having the same data. If you remember, it's copy on write, and I have multiple clones of the same data. I could run reports against each clone. And because of the shared nature, the copy on write nature, most of the data is actually using the same cache and the same RAM, the same L2 ARC, whatever.